Hello friends, welcome to yet another presentation on chemical engineering thermodynamics. Today we will study about entropy and Clasius inequality. Let's take an irreversible cycle ABA and let's analyze it. This irreversible cycle is approximated by a series, an infinite series of reversible Carnot cycles. Now each of these reversible Carnot cycles does work adiabatically but reversibly and takes heat isothermally reversibly and rejects heat also isothermally and reversibly. Now these are the reversible adiabatics for each of the process. So each Carnot cycle is within these two reversible adiabatics. The heat is received with this isothermal reversible process and the heat is rejected by this isothermal reversible process. Now this entire Carnot cycle approximates this portion of the irreversible cycle. So the entire cycle now is approximated by a series of reversible Carnot cycles. Now each Carnot cycle, whatever work it produces, it gives it to the next Carnot cycle. Now further on, the work is cascaded off to the right. Now, let's take one portion of this irreversible cycle, that is 1, 2, 3, 4. Now, this is approximated, as we can see, by a reversible Carnot cycle. The Carnot cycle takes heat QH at TH and rejects heat QC at TC. For the Carnot cycle, we know that delta S process is 0. Now the small portion of the irreversible cycle which has been approximated with the Carnot cycle also, we can therefore conclude that for that process also delta S process is nothing but 0, or change in entropy for that cyclic process is also small portion of this process is also 0. Now let's have a look at the steady flow entropy equation. Now what is a steady flow entropy equation? Let's take a control volume. My blue area is nothing but the control volume. Now the change in entropy of this control volume per unit time is ds by dt. Now this change in entropy can occur due to irreversibilities caused by the churning of the fluid. It can also be caused by entropy coming in into this control volume, okay, by way of flow, and entropy leaving this control volume by way of flow. Also, the entropy of this control volume can change if we add heat to this control volume at temperature T. We can therefore say that the change in entropy of the control volume per unit time is nothing but the summation of all the flows and their specific entropies going in and out, and adding all the heat flows given across the boundary to the control volume over the temperature at which the heat is given and the entropy generated within the control volume. Now for a cyclic process ABA, we have already seen that delta S is 0. Now the cyclic process ABA, mind you, was an irreversible process. Since delta S is 0, therefore in this equation ds by dt, that is change in entropy of the system per unit time, is going to be 0 because it's a cyclic process. The control volume, in this case, the process is happening within the control volume itself. Okay. So the change in entropy of this control volume or the change in entropy of the process is 0. We take the control volume now as the process itself. Okay. The change in entropy of the process is 0. Therefore, the change in control volume of the process is also 0. Now, for the process shown to you previously, the irreversible cyclic process, it is a closed system. If it is a closed system, then entropy flowing in and out by virtue of flow coming in and out is 0. And all we are left with the steady flow entropy equation is summation q dot by t plus s gen is equal to 0. Because it is an irreversible process, entropy is bound to get generated within the system. Now, since the cycle is irreversible, entropy generated is positive. S dot gen is positive. For an irreversible process, S dot gen is taken equal to 0, but for a irreversible process, for a reversible process, it is S dot gen equal to 0, and for an irreversible process, it is S dot gen greater than 0. Therefore, we get summation q dot by t less than 0, or we get our Clasius inequality, that is the cyclic integral of the process, the cyclic integral on the process, on the cyclic process itself, the dq by t of that process is going to be greater than equal to 0. Mind you, this is not entropy. This quantity dq by t is not entropy. All it says is, all that the cyclic Clasius inequality says it, that for a cyclic integral, that is for the, if an integral of the summation of all the dq by t is done on an irreversible process, that is going to be less than 0. For a reversible cyclic process, the summation of dq by t is going to be equal to 0. Hope you have understood what is Clasius inequality. If you have any doubts, do put it in your comments. I will try my best to take those doubts and solve them and produce videos which would be a further clarification to all your doubts. Do subscribe my channel and have a great day. Bye.